All right, today we're going to unpack one of the most dramatic stories in modern science. We're talking about the incredible promise and, well, the intense controversy of cold fusion. It's really a tale of huge ambition, a crazy media frenzy, and, what scientific proof even means. So what if you could solve the world's energy problems in a jar? I mean, just imagine it, a nearly unlimited source of clean, cheap energy. And we're not talking about some massive billion-dollar reactor. Nope. We're talking about a simple device you could literally hold in your hands. That was the staggering idea that set off a global firestorm back in 1989. Okay, so to really get why this was such a big deal, we gotta quickly cover what fusion is. At its core, it's the ultimate power source. It's the engine of the stars. Literally, it's what powers our sun. It works by smashing atomic nuclei together, and when they fuse, they release just a tremendous amount of energy. Okay, so for decades, scientists have been chasing what we call hot fusion, and it's exactly what it sounds like. It requires temperatures hotter than the sun, and these massive, unbelievably expensive machines, these things called tokamaks. But cold fusion? The promise there was to get the exact same result, but at room temperature, in a simple little jar. You can see why it was called the holy grail of physics. It seemed almost too good to be true.
So this whole thing really kicks off on March 23, 1989. This is the day the world of science was basically turned on its head, and not by a carefully written peer-reviewed paper, but by a press conference at the University of Utah, of all places.
And you have to understand, the two men at the center of all this were not some rogue inventors working out of a garage. These were highly respected chemists. You had Martin Fleischmann, a super esteemed electrochemist, even a member of the prestigious British Royal Society, and then Stanley Pons, a professor right there at the University of Utah. Their credibility is what made this announcement absolutely impossible to just ignore. And after that press conference, things just exploded. The speed of it all was staggering. Within days, this story was a global phenomenon. It didn't hurt that, by a terrible coincidence, the Exxon Valdez oil spill happened the very next day, which put clean energy on the front page of every newspaper. At first, there were even some initial reports from other labs that seemed to confirm their findings, which just fueled the fire. But then, just as quickly, the scientific community really started to push back. And this was the statement that kicked it all off. Think about the confidence here. We have established a sustained nuclear fusion reaction at room temperature in a simple apparatus. It's so direct, so sure of itself, and it makes an absolutely unbelievable claim. They were basically saying they had put a star in a jar.
But right away, this raises a huge red flag for pretty much any scientist. Major discoveries, they're announced in peer-reviewed journals, where other experts get to pick them apart first. You don't do it with a press release. So the big question is, why? Why did they do it this way?
Well, it turns out there were a few big pressures at play. For one, they knew a rival researcher at a nearby university was working on something similar and was close to publishing. Plus, and this is a big one, they wanted to secure the patent. I mean, if this was real, it would be the most valuable invention in human history, right? And then you had the media, which just grabbed onto this story and turned a scientific claim into a worldwide spectacle almost overnight.
Okay, so the announcement is out, the whole world is watching, and now the real work of science begins. Verification. The question on everyone's mind was simple. Could anyone else make it work?
And I mean, labs all over the world, from MIT to Tokyo, pretty much dropped everything to try and replicate this experiment. But as they all scrambled to get it working, a really troubling pattern started to emerge. The results, they just weren't showing up.
And that led to what is probably the single most important question in this entire debate. See, a nuclear reaction isn't a quiet thing. It leaves behind these unmistakable fingerprints, these byproducts. So where were they?
And this, right here, gets to the absolute core of the problem. Real fusion, the kind that powers the sun, should produce a storm of byproducts, especially neutrons and gamma rays. But the levels they detected, they were near background noise, billions of times too low. And here's the real kicker. If they'd actually produced the amount of energy they claimed through real fusion, the radiation would have been lethal. It would have been fatal to Pons and Fleischmann themselves. So what about those first few confirmations that got everyone so excited? Well, they were retracted pretty quickly. Turns out, those other labs found errors in their own experiments. Things like faulty equipment, or even just not stirring the water bath properly, which created this illusion of excess heat. Simple, honest mistakes. But maybe the most damning failure of all came from the Harwell lab back in England. And this is key. Fleischmann himself personally gave them all the details, all the instructions. And even with his direct help, they couldn't reproduce the results. So that whole argument that other people just didn't know the secret sauce, yeah, that was pretty much falling apart.
Okay, so as the scientific case starts to crumble, the story really shifts. You have to wonder, why did the controversy keep going? Well, the answer has less to do with physics and a lot more to do with human psychology.
There's a key psychological concept at play here called ego involvement. Basically, it's a state where your own identity and your self-esteem get so deeply tied up with the belief or, say, a public commitment that it becomes incredibly difficult to admit you were wrong. And when you look at Pons and Fleischmann, you can see they were basically anchored in self-protection. Think about it. They made this huge public commitment at a global press conference. There was no backing down gracefully. They got tons of positive reinforcement at first, media praise, grant money, and the fear of public and academic humiliation, it must have been immense. It's almost a textbook case of cognitive dissonance. It's easier to believe everyone else is wrong than to face the fact that you made a colossal error.
So for Pons and Fleischmann, at a certain point, just saying, oops, we made an error, it wasn't seen as an option anymore. The human pressures were just too strong, and they felt they had no choice but to double down.
So after all the cameras went away and the frenzy died down, what was the legacy of this whole thing? What happened next?
Well, in the mainstream scientific community, the term cold fusion basically became a punchline. It got associated with pathological science or pseudoscience. You'd hear people call it voodoo science. The brand was completely toxic.
It got so bad that any researchers who still believed there was something unexplained happening in these experiments, well, they had to completely rebrand their entire field. They couldn't call it cold fusion anymore. So now, you'll hear the term low-energy nuclear reactions, or LENR. It was a way to try and escape the huge stigma from that 1989 fiasco.
And that really leaves us with the central question of this whole story, doesn't it? Where is that line between truly revolutionary science and just self-deception? Science absolutely needs bold, out-of-the-box thinking, but it also demands rigorous, repeatable proof. The whole cold fusion saga is just this powerful cautionary tale about how difficult and how critically important it is to be able to tell the difference.